Hi everybody, this is Katie. Welcome to our third lecture on modules for CIS116, Programming, Logic, and Design. Hold on a second. Make sure you can hear me okay. Alright. We are going to go through the PowerPoint to get some definitions out of here, but we're going to keep this lecture video short because as you found out last lecture videos, we have both this video that you'll listen to and also the code with me, and we learn a lot more in the code with me, I think, because we get to do things together. So here you're just listening and reading the book at the same time. So modules, this is the topics: defining and calling, local variables, passing arguments, and global variables. Those are the things we're going to talk about. Chapter 3 in the beginning, page 81. A module is a group of statements that exist for the purpose of performing a task within a program. So you're grouping a portion of your program together that might not otherwise, or might not have previously been grouped together. So you create several different modules, also called functions, also called methods in some languages. Benefits of using modules: simpler code, code reuse, better testing, faster development, easy facilitation of teamwork, and easier maintenance. It is just how coding is done. All of our programs, all of the programs that you'll code in the future will use modules. Any business job that you have will use modules. Any program that you're looking at online will use modules. It's how it's done. So it's a great thing that we're learning this in the beginning because we can see how they're broken apart. Read through the benefits on page 82 and 83. Those will help you, for the quiz and things like that, just to understand the benefits of it. Let me give you a look at, before we go into defining and calling, let me give you a better look at what a module looks like, because I don't think we should talk about calling and defining a module without looking at one. So we have, let me go over here. We have, last lecture video I showed you this little program, this flowcharting program called Raptor. And I'm going to take this program that we had and break it apart into modules. Now as a programmer, you can decide what you want in your module. You can say, I want this part of my code in module, or this part of my code. Usually you do something that is logical. You don't just say, you don't just break it apart into any way. Speaking of which, breaking it apart, if you look at a module like a paragraph in a paper, that might help you to better understand what you're doing. So when you're writing this big long English paper and you don't have page 1 and then the end, and you have everything written out without any paragraphs, that comes back with a lot of red ink on it. That's what we're doing here in this program that we did. We get this, we get that, we get this, we calculate, and we output. But that's 5 lines of code. Imagine if you're coding a program that does anything more than what this does. You have thousands and thousands of lines of code. You don't want to have all of that from the beginning to the end without any paragraphs or without any modules. So we break it apart into modules. I'll help you at the beginning in this chapter to figure out where our module breaks should be, or look at it like a paragraph break. Where should our paragraph breaks be? Where we'll do this, let me get a Word document up here. Where this, what this looks like in pseudocode, and what it'll look like in the beginning when we had our main module. We always had a main. Actually, with Small Basic, it doesn't tell us that we have a main module, but we just started coding. But we'll code with our modules in Small Basic as well. They're called functions, I believe, with chapter 4 of that PDF, but I'll pull that up in the other video. So we have a main module, and then in here we do our calls to our modules, and then we would end main, and then we have our other modules. In the way that we're going to define them in the beginning is an input module, and then we end our input. And then we'll have a calc module, and then end our calc. And then we'll have a output module, and then we'll end that output. So whatever we had before, whatever inputs we had before would go between the beginning of that paragraph and the end of that paragraph. And whatever we had in calculations would go between, at the beginning of that paragraph or module and from the beginning to the end of that module. And then all of our output would go here. So instead of having everything in main, we break it apart into different chunks, and then we call it. I won't worry about spelling that right now. Oh, I can't get past it. Okay, so that's how you break it apart. Now, if you're looking at a visual flow of it, here's everything in one big paper without paragraphs, or one big main. We want to break that apart, so I'm going to do a new one, and I'm just going to create, see this word up here, main? That's because main is a keyword in every language, and every language has a main module. So I'm going to create an input module. Well, okay, I'll save it. So this is gross pay program using modules. So I created an input module, so I'm going to double click and I'm going to call it get input. Call it whatever you want. I'm going to go back to my main, and I'm going to make another module called calc data. Yes, I want to create a tab. I'm going to go back there to main, and then I'm going to have one that does my output data. Yes, create a new tab, and then go back to main. So in main, you have all of these module calls. These are called calls. Right here, calls to modules. So in main, you'd say go to input. And after you went to input, you want to say, okay, call my calc module. And then after you call your calc module, you'd say, okay, now call my output module. Everything goes and centers around main. So we start our program, we go down here, do everything is here, come back. So let me find my, man, I should really know computers better than what I do. Oh, this one here, I want to use this one. I was just joking there. When you hit run on your program, it starts here. It says bing, I'm going to start here. Then I hit this line of code, and it sends me down from this line of code, it sends me to this module, and then it does the line here, and the line here, and the line here. It does everything that you tell this module to do. It could have 800 lines of code in here. It could have whatever you want. If else's, decisions, which are the same. It could have switches, it could have loops, it could have variables declared, it could have a whole bunch of things in here that you're taking in. But when this call is hit in main, all of this stuff gets executed. When you hit this end, so there would be step one, it says, okay, I'm done, now I'm going back up here, and I'm going to go to the next line of code, which is calc. And then from there, I'm going to say, oh, now we have a call to calc. Okay, let's go down to calculate. So that's my step 2, and then do this line, and this line, and this line, and this line, this line, all the lines in there, and then end it. Okay, let's go back, and now let's go to output. So now we hit output, and it says, let's go down to output. Bing. You like my drawings? I hope you're following. It kind of makes sense when you draw it on here. So we go down to output, and then we do everything that's in here, 1,800 lines of code, 300 lines of code, whatever it is, and then we have end output. So then we take it from here, go back up to where it was called, and end. Because that's the next line, our program's done. So everything centers around main in these modules. Jump down, go back, jump down, go back, jump all the way down, go all the way back, and then end your program. Now you can take any program that you have written previously, just like we do in Raptor. We had that one program that calculated gross pay, and it did this. When we look at it, we get employee name and we get hours of work, and we get pay of rate. So these three things here, those are inputs. So we're going to take those three inputs and put it in that program, put it in that get input module. So I'll go over here and I'll ask those same three questions. So I take an input statement, another one, and I ask those questions. What were they? Enter hours worked. Did I have an enter name? I had three. Let's see. Hours worked. I must have. Yeah, employee name. You know what? Let me see. Oh, I don't think I can copy. Control. I don't know if I can copy from program to program. If I could type. Let me try to open two instances. Aha! I can do this. Okay, so this is the one without modules. Here's my main. So I'm going to go here. I get my input. I go over to this module tab. Now that's not what it says. So let's make it exactly like it said before. Okay. So here's my first one. Enter employee name. And I'm going to call this employee name. Enter the number of hours worked. Enter the rate of pay. Pay rate. Okay, so when we see, before when we ran our program, we only have one module main, and it did this, and then it went this and this. So when we run it in our new program that uses modules, and I hit run, let me save that and run it. Notice it starts in main, and then when you start it, start again. Let me stop it. When I started it in main, I paused real quick. See, it went to this module, and then when I play it, it jumps over to this tab. Bing. It hits this line and it stops. Bob Smith goes down 15 or 17 hours and $10.50 an hour. And then when it hits end, it goes back to main. So let's play. Ooh, I have to hit enter. Then it went back to main, and then it goes over to calc. We don't have anything in there yet. So it goes back to main and then goes over to output. Nothing in there yet, so it goes back to main and ends. So it's the same exact thing that we had in main, but we broke it apart into 3 additional modules. So we have main, which has calls, and we'll address those next. And then we have get our input, our calc, and that was an assignment statement that just said, okay, pretty nice, that said gross pay is equal to hours worked times pay rate. And then our output was this line here, right? So we take an output, and we say gross pay was my exact phrase for this employee is $ quote plus gross pay. Bang. So we still have everything, these programs, when you run them, you could run both of them in any code you want. You could run them in Raptor. You can run them in Small Basic. Anything you want. Oh, 100 hours is too many. They all work exactly the same. You get the same output. Here's my output. Here's what my variables are stored when I'm running it with modules. Let me run it over here. Bob Smith. Oh, hold on one second. My phone is ringing. Okay, hours worked. He worked 40 hours, and how much did he get paid an hour? $15 an hour? Is that what I put in? Yep. Enter. Okay, runs over here. My output's a little bit nicer than what this one is, but you can see when I put in the data, it was the same process on the user end. When I look at my output, other than my typo right here, it's the same process on the user end. So the user knows no difference. They don't see what happens. But as a programmer, so now we're looking at two ways to structure a program. As a programmer, it's much more logical and much easier to break your program apart into these things called modules. Because, how do you make that bigger? Because of the benefits of using modules. They're easier to read. They're easier to troubleshoot. It's just how it's done. It's easier to work in group projects. You could work with your partner, your programming partner on a project and say, you need to do all the things and calculate, and I'll do all the things and input. Now, it requires some planning. You need to know what you're doing ahead of time. But all of these benefits, faster development, code reuse. If I have to take in this stuff again, I just recall this module. It's a much better way to structure your program than everything in main. So we break it apart with main being the main module still, and all these different sub-processes called modules. Sound good? Easy so far? Okay, now remember, I'm just using Raptor to help you see how code works. You don't have to, or how flowcharting works. You don't have to do it with any of your programs at this point, I don't believe, or I'm not assigning it. So let's look at defining and calling a module. Okay, the code for a module is known as a module definition. So we're going to catch up on these PowerPoints here with what we've learned already. Defining and calling a module. So what we see right here is in this pseudocode, module show message parentheses. Now, let me make sure. I just want to make sure because I had to pause it. Okay, I'm still going. The parentheses are used to pass variables around. We'll talk about that in a few minutes. And then whatever you put in the inside the module from where you define it, this is called the definition of the module or the method or module header. The body is inside of here. And then you have end module. To execute a module, you write a call. So use the keyword call if you want, or just make a call, or just write the name of the module in main. So those module calls always go in main. So again, back to our little pseudocode example that I wrote over here. We have main. These are the calls. Sorry, I got all these lines here. These are the calls. I'm not even going to try to spell that. And then these are the modules down here, the individual blocks of code. So they all are separated, and the calls are all in main. There we go. Other things you want to read in this section, defining a module, they follow the same rules as variable names, so be descriptive, no spaces, usually no special characters, cannot begin with a number but can contain a number. So really the same rules with variables. The header, the body of a module, so remember this is the name of a module. You can call it whatever you want as long as you follow the rules. In that first program, I called mine input, calculate, output. I would probably be more specific in the future because input is typically a keyword to read in data sometimes in some languages. So you might say input data or something like that, and then calc gross pay or something similar like that. But you call your modules what you want. Following the rules, and then the statements inside are the body, and you can put whatever you want in there. Again, here is an example in main. Now main doesn't just have to include module calls. You can put other things in there like a display message. So here in this example, here's main, display, I have a message for you. Call this method, goes down here, displays hello world, and then it comes back and displays that's all, folks. So what the output of this will look like is I have a message for you, hello world, that's all, folks. So you see how it jumps down. Flow charting, this is the flowchart symbol in Raptor, and if you're using Visio, it's called a module or a function or a method. So it's just a little different symbol, but it's a process box with two other rectangles on the ends. Okay, top-down approach. This is just a way to design your program. And then there's also hierarchy charts. So you can read about those on page 88 and 89, where it shows main and then all of the modules that are inside of main, or not inside of main, under main, and then modules that might be called within those modules. So here's an example. Main would call get input, and then get input would call get hours worked and get hourly pay rate. Now, I don't know that I would necessarily break your program down into that many processes or that many modules, but you could if it became more complex. And then you might calculate gross pay, and then overtime and withholding, and then this broke down into taxes and benefits. So the purpose of these charts are, again, just to graphically see where your program flow is. Excuse me, local variables. Now, this is important because when we declare variables outside of a method, well, when we declare variables inside of a method or a module, it can only be used inside of that module. When you make global variables, you can use them in any method or module. So page 95 talks about local variables. It's declared inside a module and cannot be accessed by outside modules. Different modules can have variables of the same name, excuse me, and those modules can't see other variable names. So, for example, I'm not going to go back to that craziness in that drawing. But let's say, so I'll erase it and start again. Let's say that I want to have a main module here. Make my thing a little bit bigger, and then I'd go and I'd have my end main. And another module for get input. and then end and get input. So if I here say, well, let me do one more. Let me do another module called display data, and then end display data. Okay, so these are all different. This is one. Oh, goodness. This is one module. This is another module. A different chunk of code. Let's go purple. And this is a third module. And again, everything centers around main. I'll go red. Now, in main, that's where you put your calls. So I would say get input. Oh, I guess we could use the keyword. I always forget that, but remember, pseudocode is just what you want to write so that the person reading, or so when you're trying to troubleshoot, you can figure out where your logic errors would be. Okay, so here's main. It's going to go down here, run that, come back, go down here, run this, come back. If you have a variable that's defined inside of get input, so I would say real, or let me say string name, or username, and then I want to username, well, display what is your username, and then input username. So you have this going on here. This is called a local variable. It has local scope. Scope means the part of a program that can access, or that a variable can access. So it's part of the program in which a variable may be accessed. That's just what I said twice. I defined it in my head and then I read it to you. But a variable is visible only to statements that are inside that variable scope. So when I reference it here, this is all within the scope of the same module, so it works. But if I go down here and I just say, okay, I'm going to display, nope, I'm sorry, I'm out in the middle of nowhere. Let me go back down here. If I go down into this display data module and I say, okay, now let me display the username is plus username, and I expect it to print out whatever the user entered in here, it's not going to work because the variable is local to this module, and then this method here cannot see that. It doesn't have this variable has local scope only to this method. This method or this module cannot see it. So that causes a problem. Read about local scope, and the alternative is global. So let's look up here. We mentioned when we define local variables, they can module names can have the same name, can have the same local variable names because they can't see one another. So here's an example where we get two ages, declare integer age, input age, declare integer age, input age. This is a problem because they both have the same scope. They are both declared as age inside the same method called getToAges. So see, cause an error. If you define those outside or in a different variable, then you don't have a problem. So here we have number and square and then number and half, but they're in different blocks. This one is in show square and this is in show half. So because they exist in different modules, you don't have a problem with duplicate variable names. So this is legal. This one's not legal. The alternative to a local variable is a global variable, but we'll talk about that at the end. Passing arguments to modules. So sometimes one or more pieces of data are needed, so it has to pass variables around. these are called arguments, and then they're sent into a parameter or a parameter list. So read these terms. I'll refer to these in our future videos. An argument is any piece of data that's passed into a module, and a parameter is a variable that receives an argument. Multiple arguments passed sequentially are called a parameter list. Here's an example, but let me go and show you mine here. So let's say that I want to change my call for main, and I'm going to call it, my call for display data. I'm going to take it out of main, and I'm going to put it in my get input module. So now this one becomes purple. So let me format that. So I moved my call down here so you can see in my purple input. So now I'm calling main. I get input. I come down here. I get the username. I just call display data. So I go down here and display the data. Well, see this parentheses? This is where you pass arguments. So because the username is local to this module here, but I want to use it in here, I have to pass it down. So in the purple module, I need to take this variable and pass it down to here so that I can use it right here. So I'm going to make this an argument of this. So I put in here username. So this, in my parentheses, this is an argument. By the way, the 2 forward slashes, again, that's common documentation. So the argument is username that I'm passing down to display data. Okay? Now, in order to accept it, I need a parameter. So I say the data type, which is string, and then I'll use the same variable username. Now, so this is called my parameter. And if I had multiple parameters, it's the parameter list. So now I pass it down and I can use it. Now you notice how I use camel casing here and I said user capital N. Now that wouldn't work because this is a lowercase. So even though it's pseudocode, I'm going to correct that just so we know. So that is some examples. That's an argument, and this is a parameter list, and now I can use it down here. It's a very important concept when you get into real coding in languages. Now, small basic, I'm not sure how it we don't declare variables in small basic, so it shouldn't matter, but we'll see. We don't declare them, we just use them. But in other languages, again, you have to pass them around as arguments. And you should know those terms because we're going to reference them in the quizzes, and if we do any pseudocode, you'll have to declare it. Here's another example in the presentation. Pass by value versus pass by reference. Again, this is important when you get to actual programming. For our class, we're not going to probably encounter these concepts, but I want you to read about them on page 105, because they have to do with returning values. Let me just see what depth it goes into on their examples. Oh, that's it. Okay, pass by value. What that does is it passes a copy. So if you did pass by value, like in this doc, this is pass by value. So the original value is stored here, and a copy is passed down. So when you go back out of that method, it's back to 0, or it goes back to no data. If you want to keep the value or pass kind of a pointer to the exact value, you pass by reference, so you do ref, and then it points directly to that variable. So there's two concepts when you pass variables around. Pass by value is a copy. It's one directional communication. so you take a value, pass it down, you use it. It doesn't go, when it goes back, it's not changed. It's one directional. You send it down there, it's used, that's it. Pass by reference, two ways. So you can pass a variable down, you can use it, change it, whatever, and when you get back out of that method, it's changed, or that module, it's changed for good. So this is a really big concept when you're coding in real languages, but I don't think it's going to affect us in what we're learning in Small Basic. Something important for your next classes for sure. Global variables are variables that are accessible to all modules. Now, global variables should be avoided because it makes debugging difficult. Your variables always exist. You could have a lot of errors with duplicate variable names. It's just not a really good way to code. So what a global variable is where you would take this program. I can copy this and make another example. This is probably the best way. You do the simple program passing variables. But if you wanted to make a global variable, you would take it from here. So I cut it out of there. I'm going to I'll cut it out of there. I'll go up above main and I'll say global, and then I'll put my variable name. And let's make this one pretty green. So now I'm going to delete this call and get input, and I'm going to put my call back up here in main. Display data, because I don't have to pass it down anymore. So this would be a global variable example where my variable is used. Here's the whole program right there. Okay, my variable is declared up here. Global variable. Because it's global, it means it's defined up here and outside, and main can use it, get input could use it, display data could use it. So you don't have to pass it around. I would take this out. I don't have a parameter list. I don't have to call anything. It's just out there. It's this big global variable that's floating around the whole program. So you don't have to pass it around. It's a lot easier to code like that, but the problem is it always exists and it's always taking up memory. So creating global variables is not really one thing that we want to get into the habit of doing. So that is this chapter on modules. Make sure you read the chapter. There's some really important things in there. You should be able to answer all of these questions in the review questions that are on page 116, 17, 18. And then with the Code With Me, we're going to do some programming exercises that start on 120. You know what would be a really, really good idea for you guys? On page 120, there's the debugging exercises. Those are a really good way to find the errors. And I could even start the Code With Me, maybe I will when I make that later, is start the Code With Me and look at those debugging exercises and try to figure out where the problems are. That will help you to understand the chapter. So thanks for listening. Again, I'm going to save these. If you want a copy of anything, you just let me know. Oh, sure, I'll save that. But read the chapter. That'll help you to understand it. Thanks. Have a great day.